Up. Okay, what we're going to talk about now is IP version 6. I'm going to open up my slideshow and talk from it and draw on the board. Hopefully it will show up well in the finished result. Go to course materials, goes to IPv6. You guys can screen stream this if you want. And what I'm going to cover here is addressing today and alternative technologies on Friday. Okay, so we're going to talk about the structure of IP address, how computers get them, describe the types of IP address, IP version 6 address. One bullet point that's not in there is we're going to learn, you guys are going to learn how to subnet IP, which is, you're going to say, this is way cool. All right, so let's rock and roll. Why is it needed? Well, addresses are running out. They've been saying that since 1995. And finally they actually did, didn't they? Last year they ran out of network IDs. And the things that really saved us was network address translation. You know, we don't need public, the only public IP address we really need is on our border routers that connect to the rest of the internet. And all the rest of it, you know, you set that border router up as a NAT router and call it a day. Essentially. Our routing tables have gotten quite large with IP version 4, and there's some kind of mechanism for managing these router tables with IP version 6. IP version 4 isn't particularly secure natively, and they added technologies to that. But IP version 6 is, and it provides better quality of service. Yeah, they're the temporary solutions. Let's take a look at the next slide. China is going full tilt bozo at IP version 6. That because they have a lot of computers that they have, and they don't have enough IP4 addresses. Okay, so there's some websites that you can go to check out IP version 6 and see if you actually are using IP6 with that third one down, kame.net. Okay, so IP version 4 uses 32 bits, which gives you 2 to the 32 potential IP version 4 addresses. And if you know anything about IP version 4, you know that we don't have that many addresses. We have whole blocks of them that aren't used, especially like Class E. Probably a lot of Class D addresses aren't being used. But at any rate, 2 to the 32 is approximately 4.7 times 10 to the 9th, which is 4.7 billion addresses. It's not enough, right? Well, with IP6 we have 2 to the 128th addresses. There's the full number. I don't know where I got that, but I think that looks correct anyway. If you punch that on a calculator, maybe you can figure that out. Double check my figure there, but it's a lot. Supposedly it's billions per every square meter or something like that. 3.4 times 10 to the 38th addresses.
It should be 4.3 billion.
Oh, is it?
Yeah.
Okay. Good enough. So, IP6 addresses are written in hex, but at the base of them, like IP4, it's ones and zeros. Okay. It's written in hex for our convenience, because we can more easily decipher hex once you learn how to do it. Okay? Could you imagine writing an IP version 6 address on these boards? You know, I practically take the width of a board for 32 bits. I'd have to walk all the way around the room at least once to write these things as in base 2, essentially. So it makes it a little bit easier. So it's IP6 are broken up into 8 blocks of 4 hexadecimal digits. Well, and there's an example there. So it might be something like, A123:0013. Each one of these is a block. Notice it's 2 bytes long. Okay? 1, 2. I got to count these because I lose track as I write them up. 0000:17BA : let me see, I got 4 of them, right? 1, 2, 3, 4. 1963 colon A F B 1 colon 6. Two more. 1, 2, 3, 4, 5, 6, 7, 8. Okay, they look like that. Okay. You can say that each one of these is a block. Now, sometimes you'll, well, I'll talk about collapsing in a second. No, maybe I'll go ahead with that right now. Okay, so I have zeros in here, and one of the things we can do is we can make them a little easier to read by eliminating zeros. Okay, in this case I have one block that's all zeros, so I can rewrite this address. What I can do is I can eliminate leading zeros and one block that's all zeros. One block that's all zeros. So I could write this A1, 2, 3 and eliminate these two zeros and write this as 13 to shorten it up a bit. And it's understood that the bytes to the left, or the hex digits to the left, are zeros. Okay, and then this one I can just do like this. The rest of it I'm going to have to write it as is: 17B A colon 1963 colon AF B1 colon 1, 2, 3, 4 colon 5, 6, 7, 8, like that. Make sense? Okay. If I have a situation like this, A1, 2, 3 colon 0, 0, 0, 0 colon 0, 0, 0, 0 colon 0, 0, 0 colon 0, 0, 0, 0 colon 0, 0, 0, 1 colon, let me see how many blocks, 1, 2, 3, 4, 5, 6, 0, 0, 0, 0 colon 1, 2, 3, 4, like this. I can also collapse this, but notice I have two blocks that are composed of zeros. I can only collapse one of them. And the reason is, if you collapse both of them, you won't know which one has four blocks of zeros and which one has one, or does this have two, and so forth and so on. So you can only collapse one. So I'd write this one as 1, 2, 3 colon 1 colon 0 colon 1, 2, 3, 4, and I've collapsed it. I have to put this in here to indicate this is one block, at least a 0, or put all 4 zeros in there. Either one will work. And when you program that into the system, that's what it'll let you do. You see what I'm doing? Okay. Questions? I think that's it. 1, 2, 3, 4, 5, 6, 7, 8. Right. So this I could collapse to 1763 colon 1, 2, 3, 4 colon A, B, C, D colon 0 colon 0 colon 1, B, A, C, like that. So that's how you make it a little bit easier on yourself, and you can type it in and program it into the operating system that way. You don't have to type all those zeros. I don't want to have to type a bunch of zeros if I don't have to. So you can see the immensity of these things, right? Yeah. Okay. I'm going to give you an exercise to do that so you understand that.
Question?
Yeah.
Why didn't we do the colon in the last series again?
Here?
Yeah, why did we do 0 instead of just colon?
Because if I do this, I go 1763 colon 1, 2, 3, 4, and I go colon A, B, C, D, and I go colon, colon. I go 1B, A, C. The question I'm going to ask you now is, how are the blocks? We've got 1, 2, 3, 4. We've got 4 blocks of zeros, right? How are they distributed between here and here? Is there 1 here and 3 here? Yeah. It's not readily obvious until you kind of ask that question, right? You guys see what I'm talking about? Yeah. So you can only do 1. And typically you're going to do the longest one rather than the shortest one. You got to get these zeros in here. Tell it that those are single blocks. Yeah, good question. I'm glad you asked that. Excellent. Cool. So now you know more about IPv6 than you did when you walked in here, right? Okay. So I'm going to take, and we'll go back over this thing, and I'm going to tell you about the anatomy of this thing. Okay. We don't use subnet masks, but we do have network IDs and host IDs still. You know, it's like an area code and a phone number, isn't it? It's the same idea. We have to identify a network portion and a host portion. So the first 64 bits, or 4 blocks, generally speaking, are the dividing line, although that's kind of an overgeneralization, as you might imagine. Okay. And if you go here /64 from your CIDR notation, that's 64 bits. Okay. Well, they further subdivide this thing out into the first 4 blocks, okay, which is 48 bits, is something called the global routing prefix. I think that's on the next slide, if I'm not mistaken. Oops, no it isn't. But I'll go ahead and see if I can get to that slide.
There it is.
Whoop.
Yellow.
Page up, page up, page up. Yeah, there it is. First 48 bits of global routing prefix. The next 16 bits are the subnet ID. And now, the documentation that I used when I created this slide and talked about it, it says that gives you 16 bits for subnetting. You know, how many, you know, that's 2 to the 16th different subnets. Over 65,500 subnets, right? Like 534 or something like that? Well, that's not quite correct. Which we found out later, because what you really can do is you can subnet all the way down into here, generally speaking. So the terminology is a little bit uncertain, isn't it? You know, but we found you can subnet all the way down in here if you want to. Okay. If you used all of these bits, you'd be a /64. You just use the global routing prefix. What would your slash notation be? For your network ID.
Can I say that again?
If you didn't subnet it using the subnet ID, you just use this as your network ID here, your global routing prefix. Okay? We'd be /48 because we're talking about 48 bits for the network. These are 16 more. So 64 minus 48 is 16, or 48 plus 16 is 64. Does that make sense, guys? Am I going too fast?
Oh, yeah. Stupid question. Each one of those blocks is, you said 16 bits, right?
Right. Mm-hmm.
Okay.
Okay. Global routing prefix is 48 bits, or 3 blocks. Subnet ID is 1 block, or 16 bits. Okay. So, there's a bullet, by the way, there's a bullet point on there towards the bottom. The net, it says the only allowable CIDR notation, 48, 64, and 128. That's not really true. That's old information. That's not true. I left that on there so that in case you do see that, It's not really true because you can subnet this thing out. In order to subnet this thing out, however, you have to be able to translate between hex and base 2, okay, in binary. And that's the key. Questions?
How do you get /128?
That means you're using all the bits. Right?
For a host?
Yeah, so
So would that be broadcast then? If you're doing that?
no broadcasts there.
Oh.
Okay. No broadcasts at all. And I'm going to talk about that in a second. Let me hold off on that question because I have to think about that. Okay. So generally speaking, you'll read this a lot of places, is these are the bits that are the host ID bits. But that's not totally true either, because we can vary which bits are used with the host ID simply by varying the slash notation, just like we did with subnet masking. Okay, I'm gonna show you how to subnet this in a little bit. First thing I want to do is the next thing I want to do is I want to go and I want to talk about the different types, sort of like Class A, Class B, and Class C, but a little bit different than that. First one, let me see, I should have, in fact, I'm on one of the slides now. First one I guess I'll talk about is a global IPv6 address. And the first block of the global ranges from 2000 to 3FFF, like that. See those? You got a global, okay? And this type of address is like a public IP version 4 address. It's routable on the internet. Essentially, what you do is you get this from whomever rents it, Network Solutions or whatever. And you got that. You've got that first, and it covers the global address you get from Network Solutions. The first 4 blocks.
Is this global address here like the first 16 bits?
No, it's still actually the first 48 bits.
Okay.
No, it might be the first 64 that you get. I can't. Don't quote me on that. But you'll get something like this: 2050 :1791 :1832 :1234 like that. And you own all this address space back in here. This portion, however, is yours for subnetting. This portion, oh, no, I'm wrong. This portion is used for your subnetting. This portion you're stuck with. That's what you get.
Okay.
Okay. So you got a lot of address space. You know, I don't know if they assign this to you or you have any variability here. I kind of think you might get that assigned to them. Yep.
What is the /3 on that example? What's that referring to?
That means that the first 3 let me think about it. First 3 bits, which would be a combination of 0, 0, 0, that would be right. 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. I don't know. I'd have to think about it. I can't remember off the top of my head. I'd have to analyze it. It has to do with this range here, but I'd have to check it out. I can't remember. Okay. Okay, so you get this global routing prefix from them, and you subnet it out here. Actually, like I said, you can subnet it further, but we're just going to subnet in here when we get to it. the main thing about global IP version 6 is that it's routable on internet, okay? And it's just fine. Link local. Everybody gets a link local. Every interface in your machine gets a link local. It's like the 169 APIPA address, okay? And it starts out with FE80 always. So you see an FE80, that's your link local. It's not routable, and it doesn't go away when you assign another address to the interface. Let me show you what it looks like. So I go here to command prompt, I go IP config. Let me see if it'll show you with just IP config. Okay, there is my link local address. There's one there, and there's one there. And a machine automatically assigns itself one of those addresses. Okay. Now, if you notice anything that I left out about that address? There's a percent and there's a number on there. The problem with link local addresses is if you have a machine with more than one interface on it, they're each going to get a link local address with essentially the same network ID. You got FE80 61 over here, and you got FE80 62 over here. The machine's going to get confused about routing of these things. They're not going to know where to send packets. But that percent sign is a way of identifying which network it's connected to. Okay? So this might be %1, and this might be %2. And so on this side, there might be another box over here with FE80 :75, and it will have a %2 on it also, so that when he pings FE80 :75, the machine knows to pop it over onto this side. If he pings something on this side, such as FE80 :76, it's going to have a %1 tacked onto the end of it, so he knows it's on that side. Yeah?
How high do those numbers go?
I have no idea. How many nicks can you put in the machine? It's a good question. I have no idea. You know, that's what that's for. Okay. So this is used for basic communications. This thing is going to have to communicate with its neighbors when it first starts up automatically. For one thing, when this thing first starts up automatically, it doesn't have an IP address. It uses this to communicate. And the reason why it uses this, one of the reasons it has that it needs this to communicate is that there are no broadcasts anymore. If you know anything about DHCP, DHCP uses broadcasts. Can't do that here. They took them away. No more broadcasts. Okay, and I'll return to that in a few minutes. So this is a link local address used for basic communications, like an APIPA address, like the 169.254.x.y, whatever it happens to be. Okay? There's another one called site local, and that has a format, or the format FC00, I believe it is. Let me check my figures. But a site local, and it's not really all that important, FEC0, FEC0, the status of this thing, they keep changing their mind whether or not they're going to use this at all. If you see this address somewhere in some documentation or on some test, that's a site local. It's not routable either. I'm not even sure why they came up with this, decided to use this address. Okay, there's another one called a unique local, and that's what we're going to use here. And a unique local is just like a private IP address. Not an APIPA address, but a private IP like 10.0.16.5 or 192.168.0.1. It's almost exactly the same. They can route within your organization, but they won't route outside of the border router, out onto the internet. Does that make sense? Okay? So those all start off with FD 00. Okay? And that's what you're going to assign to your machines. Because then we can play with it all we want. Okay? So what we're going to do is we're going to assign addresses by collapsing the zeros to make your typing easier. Something like this. FD 00 colon 1 stuff like that. That's what we're going to use. So I don't want to force you to type all that stuff. I don't see that that has any purpose. Unique local. Questions about those? Okay. IP6 unicasts. Site local, link local, unique local, and global are all unicast addresses. No more broadcasts. Okay. And we have multicasts though. Okay. It's just like IP version 4 multicast addresses. It's sent to a subset of all possible hosts. Okay. So just like streaming audio and video and that kind of thing uses multicast, we can do that. There's a new one called Anycast, and this is mainly a routing kind of issue. And an Anycast is like a multicast, but it's sent to a subset of all possible hosts, but in a certain order. Okay, let me show you these. Okay, so there's what a unicast looks like, one-to-one relationship. There's what a broadcast, one to everybody, which we don't have here, only in IP version 4. There's a multicast, one to many. And here's an Anycast, one to many, but in a certain order. And that way you can get routing tables and that kind of thing distributed in a sort of logical fashion. Right? Okay, that's the header of an IP version 6. It's larger, it's got more fields on it. Questions? That makes sense? So let me see if I can remember how to subnet. Let's take this address I have up here in subnet. And we'll just take that off here because the host ID is going to go in here. The nice thing about this, in some ways it's easier than, say, IP version 4. The only thing I'm going to worry about is this block. Okay? So right now I get this address from Network Solutions, which is a /48, right? So let's borrow some bits just like we did in IP version 4. Exactly the same process. So I'll say let's go from /48 to /52. How many bits am I borrowing from here? 4, right?
Which would be
Okay.
1.
So that's going to look like that. 1, 2, 3, 4. Okay? Okay, so we're using 4 bits. Everybody know what that kind of data structure is called?
Nibble.
That's a nibble, right? Okay? So how many nibbles are here? There's 4 nibbles, right? So what's the next nibble in the CIDR notation, in the subnet mask, which we don't call it that? They're zeros, right? Like all the rest of them are zeros. Okay? That goes under there. Again, using a /52, that's what that looks like in binary, right? Okay. So we want to know what the network or the subnet ID in this case is. Well, all we got to do is take this and bring it down here, which is, and of course the 7 is over here. Let's see, 8, 4, 2, and 1. And if we want to bring the B and the A down, we go, let's see, B is equal to what?
11.
11. Okay, so that's 8 and 2 and 1. And the A is 10, right? 8 plus 2. And then we just do the same ANDing process that we've done before. Draw this line here. Network bits, host bits. So the network ID in this case is A123 colon 13. I'm going to collapse that one. I'll go over here to this, and I'll collapse that, and we'll go here, and it's 1, colon, colon. There's my network ID. You following from, you remembering from IP version 4? Is that you putting that together? The reason this is colon, colon is because all those bits are off for the subnet ID.
Question.
Uh-huh.
So the bottom with /52, that's basically up a little more. Yeah, that one right there. So that's basically like a subnet mask, but it's not because it's.
Yeah, we don't call it that, but it works exactly the same way.
Okay.
Yeah, it works exactly the same. We just use excited notation. 6 of them and a half a dozen of the other, right? Oh, I know all you newbies, I know the secret of slash notation, right? There you go. Isn't that cool?
So you can do 2 double colons when you subnet?
Well, in this case, see what I'm saying. Well, that's a good question. I might put a 0 in there. That's a good question. I might do that. Okay. But yeah, I think I would. And come from there.
So you can put a 0 in it then?
Yeah, I'll put a 0 in there because it's one block. So I know there's 1, 2, 3. This is in the 4th block. Yeah, you better do that. Okay. So all the rest of these, as far as the subnet ID is concerned, they're zeros, right? And the host ID, well, it's going to be colon, colon, all the way over to here. And then we go, in this case, the ones here, and then we'll have to put these bits down without the 1, right? Okay? So it'll be 0,
0, 7, BA.
BA, colon, the rest of that crap. Right? Let's see. 1963 AFB1 colon 1, 2, 3, 4 colon 5, 6, 7, 8. And that's my host ID. Or machine ID if you prefer.
Exciting.
That's subnetting. You can subnet whatever you want. Let's try another one. Let's make it a little bit easier. Let's see. F 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2. Okay, so we've got that one. And let's say, okay, let's say I need 12 sub-networks. How many bits do I need to borrow?
Start with 48, right?
Yeah, you got 48, so you need to borrow some more, right?
3.
Okay, well, 3 do it. 2 to the thirds. 2 times 2 is 4 times 2 is 8. You need 4, right? So you're going to need 4 bits, right? So if we expand this down to here, like so, we're going to go, well, as far as masking is concerned, 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Like that, right? That's the way we're going to mask it. And so this is going to be a slash 48, 49, 50, 51, 52 again, right? I didn't do that on purpose. That's just the way it worked out, right? Okay, so A, B, C, D. So an A,
10.
equals 10, which is 8 plus 2. A B is equal to 11, which is 8 plus 2 plus 1. A C is 8 and 4 is 12. And a D is 13, which is 8. And 4 is 12, and 1 is 13. Did I get that right? Correct. Okay, so there's that IP version 6 portion, and there's the mask. And of course, we drew the line right here. So the subnet ID is going to be 8, and 2 is 10, which is A. Follow? Everybody follow? Yeah. And 2000, 1900, 1800, A. And then colon. Okay. And of course, the host ID is going to be this, which is, I guess that's B, isn't it? It's colon B, C, D, E, F, 1, 2, 3, blah, 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 blah. These all the rest of it, right? You guys follow? Did you do one of these? Let me give you one. Let's see how well you do. And you can try it. One, two, three, 4, 5, 6, 7, 8. All right, and we're going to go /59. Right? So work that guy out and see what you come up with. Remember, 48 bits to here, so you need 11. How many bits do you need out of here?
11.
Yeah, 11.
11, yeah. So you need 11 bits. Work with 11 bits, see what you get.
What's the second to last one? Is that 1935?
This one, yeah, it's 1935. Yeah. That doesn't matter much, does it?
Are we looking at the AF1 screen or the EF?
Oh, yeah, I got that wrong. Thanks. I'm a little off there. So yeah, we got to look at this one here, don't we? Remember this, Doug?
It's starting to move some gears.
Yeah, I had to pull it out. I didn't know if I could pull it off or not. I had to pull it out of my memory. I'm going to pass out this ARP exercise. So I think what I'm going to do is there's some more that I need to cover before I give you the IPv6 subnetting exercise. So I think I'm going to wait till Friday to give you the rest of this, because I think I may be giving you enough information as it is, and I'm not sure you can absorb it all today. I probably couldn't if I was sitting next to you. Give you the ARP exercise, and I'll give you the IPv6 exercise that has you go through and determine which type of IPv6 address it is and how to collapse the zero. I think it's about time. Yeah, hang on, I've got them in here.
Sounds good.
Is it a unique local? Is it a site local? Hey Doug, would you pass this guy out? These out to these guys? Site local, link local, that kind of thing. Oh, actually, give me the ring. While you're doing that, I'll record who's on first.
Good luck with that.
I'll get to you in a second. Let me finish this off, and I'll get to you. If I forget, just grab me.
George, I'm turning in 1, 2, 3.
Okay. And then here. Thornhill, Matt Wallace, and Joshua. Okay, you guys got the answer yet?
Get back there.
I did.
Let me see if I can do it. 59, right? So 59 is 1, 2, 3, 4. 1, 2, 3, 4. 4 and 4 is 8, and 3 is 11, right? Yep. 12, 13, 14, 15, 16, like that. And so we've got AF here, and A is 10, which is, of course, 8 and 2. That stays the same. F is all of these. 1, 2, 3, 4. And 13 is 0, 0, 0, 1. And that's my dividing line. The rest of these will be zeros, of course. Or will come zeros. So your subnet ID should be 2001:11AB:A/F10:colon, right? Is that what you guys got?
No.
AF00.
The one doesn't.
AF00?
You drew the line in the wrong spot.
Did I? Oh yeah, I did, didn't I?
Yeah, there you go.
I did look a little funny, didn't it? Yeah, I drew the line in the wrong spot. There you go. AF00, thank you. Okay, that's how to subnet. Tell you what we'll do is on Friday, we'll do this again, and I'll show you some other things that you need to know to do the subnetting. Yeah, Brian.
So the line's based on the /59.
Yep. Just like we talked about in IP version 4. That's the dividing line between network bits and host bits. It's that in a nutshell. You know, everything else is line running. Okay. Stop recording.